identify where informity site, similar to bloodshot, identify the seed. Okay, the seed. Here, informity site. And this one explains informity site. At least two different kinds of nucleotide represented in at least two of the sequence. Understand? I explain here because you do assignment. Okay, now, number one, position one, any nucleotide different or not? No, the same nucleotide, that means non-informative site. Number two, G in A. Okay, A present in how many sequences? Only one. So that means also not satisfied. At least two of the sequence. Because present in only one. So that's why informative size. And that's the same for position 3 and 4. Position 3, even different neurotype, GCAT4 neurotype, but each one present on only one sequence. So that's non-informative. 7 and 9. 7, GC, that means at least two different kinds of neurotype. G present in sequence 1 and 2, that means two sequences. C present in sequence 3 and 4, two sequences. So the second, right here, at least two of the sequence also satisfied. So that's why position 7 and 9, that is informative site. And at informative sites, program will calculate score. Position 7, we have GC. Okay, GC. And G represents run sequence 1. G represents run sequence 2. C run sequence 3. C run sequence 4. If put 1 next to 2, 3 next to 4. G, so that's why 0. Okay, because we have GC only. If C here, compare C 0. C compare C here 0. Only GC 1. Okay, score 1. That's 3, number 1. 3, number 2. We change the position. Now we move sequence 3 to this position C here. Okay, C compare with G 1. G compare with G 0. Okay, just score it. If different, score 1. The same, score 0. So that's why you have 3, 2, 1, 2, 3, 1, 2, 3. And 3, number 3 here, the value also 3. That's position 7. Position 9, applying the same principle. Position 9, 3, 1, got 1. 3, 2, got 3. Okay, 3. And then the total, 3, number 1, only 2. And program will do the 3 based on 3, number 1. And 3, number 1, 1 next to 2, 3 next to 4. That's very simple example for you to understand how program process with the methods maximum possibilities. When program identify all the informative position, program will retrieve for each position and combine them together and generate one tree for you. So that's why, look at here, the number of rooted and unrooted trees. Even only 4 organisms can build how many trees here? 3. Okay? And the number of organisms compared in trees, this one you have formula. Formula applied for rooted tree and unrooted trees. In the table here, the result. at home, you apply the formula to calculate whether you get the same result or not. The same result or not. So new number of trees depend on how many organisms you compare. But the program generates only one tree for you. Only one tree for you. That's the formula. Unrooted tree and rooted trees. Maximum likelihood also the characteristics also have the other methods. Okay, many methods to build the trees depend on program you run. The last step, assessment of the reliabilities. Because build the trees have one organism next to the other organism, we need to assess whether reliable or not. In the program, we apply one approach we call bootstrapping. The most used method to measure the robustness of the tree topologies. Given a branching order, have consistently the algorithm for branching order in random Bernoulli version of the bootstrapping. So what it is? The first one, you have the data you input into program. Okay, program. How many sequence? 1, 2, 3, 4. And the length of the sequence 1 to 10. That means 10 column. Okay, original data. Now, how program run the bootstrap? Program will create what? Artificial data set. Artificial data set or pseudo sample, the same name. Pseudo sample or artificial data set. How program create artificial data set obtained by randomly sampling column from your multiple sequence alignment. Make the data set the same size and original. So the first one, how to create. Okay. The first artificial data set we call resampling number 1. 1, 1, 1. 1, A. You see A. Also column 1 on A. Column 2. What the sequence in column 2? T. Sequence in column 3. G. Can you see it? So, and then the length, the same size, how many column? Here, 10 column, and then the data set here also 10 column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 4 sequence. Okay, so which column go to the artificial data set? Randomly. The program pick up randomly. So that's why many column 1 here. Okay, and then continue with the other data set. Resampling 2. Now more column 3 in this data set. So program will create artificial data set. For what? And then build the trees. 100 or 1,000 bootstrap replicates. So 100 or thousands. So that means if you set up hundreds, program will create 100 artificial data sets. 1,000, program will create 1,000. So that means you set up bootstrap value. 100, 500, 1,000. Higher value, more reliable. But the process will be longer. Okay, because many replicates, program have to create the data set and build the trees. Take the time to process data. And when build the trees, for example, based on this one, the original here, 1, 2, 3, 4. Okay, 1 next to 4 and 2 next to 3. That's original trees. And then when we create the artificial data set build the trees. Here, 1, 3, 2, 4, difference. Okay, if difference, count 0. For data set number 2, 1 next to 4, 2 next to 3, the same, count 1. And then based on that, observe the percent of cases in which assignment of the place in original tree supported by the bootstrap replicates. Observe percent. Percent of, here, percent of the same trees. Okay, percent of gains. The bootstrap tree of branch given value of 1. Repeat many times, generate many trees, and then based on that to understand percentage of times if interior branch given a value of 1 computed, known as bootstrap value. And bootstrap value, that means the confidence value, the confidence bootstrap confidence. Bootstrap value less than 95%, very high confidence. Less than 75% high confidence. Smaller than 60% low confidence. So based on the number, and I show you the red number, that's the bootstrap value. And the bootstrap value, now you understand how the bootstrap value generate. Depend on the bootstrap you input into the program how many times, how many replicate, 100, 500, slash-wise. For the option, also important, I need you copy that before you run and you report to the, you pay to the report. Because if you set up the bootstrap value different, the output also different. And again, you understand how to create artificial data set on pseudo sample, because you also have one question for this one, for assignment. Which methods is the best? No, cannot say that. Cannot say that. Depend on your data. The quality of data, the more important. The more important. If your data good enough, doesn't matter which methods you choose. The tree are not the same. Are not the same. Okay, we will run mega. You have 15 minutes break, and then we run mega. And you bring